So far, we've looked at minimizing average cost, but that's only part of the picture here. Usually we want to ask, how do we maximize profit? Right? That's the money that we actually make, the money that we actually gain. So before we talk about that, let's first talk about revenue. Right? Revenue is just the amount collected after producing and selling Q items. Right? So this is basically the amount of money in the register at the end of a day of sales, let's say. Right, so this is before you subtract for your costs, before, taxes and all that. Right, so this would be the revenue function. Okay. So with the revenue function, we can create average revenue and marginal revenue, just as we did with the cost function. Average revenue being the total revenue function divided by Q, and the marginal revenue being the derivative of the revenue function. Right? So what is marginal revenue? Well, you can think of it as approximately the additional income gained by producing and selling one additional unit. Well, one way you can look at this is if you hold your sale price on an item constant, like you never change your sale price no matter what, then the marginal revenue is just how much you sell that item for. Right? However, typically you'll vary your sale price of an item based off of, changing amounts of production, right? If you produce very few of something, it's typically expensive to produce it, so you'll set a high price point. But if it becomes cheaper to produce something, you can lower your price, but still gain more in profit. So we'll sort of look at that a little bit. Right? So, an important question to ask is, how do you maximize profits? Right? So we're not necessarily focused on increasing revenue. Right? Increasing revenue is great, but if we're also increasing costs massively, then that's kind of a bad thing. Right? If costs increase by a lot, increasing your revenue is pretty meaningless. The thing we really want to focus on is maximizing profits, which is how much do we have after we subtract our costs from the revenue. This is sort of our net gain in money. Right? So how do we maximize profit? Well, what we want to do here is, if producing additional units adds more revenue than cost, it'll increase profit. So we want to do that. Right? So in terms of derivatives, what we're doing here is, right, the derivative of the profit function is going to be marginal revenue minus marginal cost, because profit is just revenue minus cost. Right? So this profit function here, it'll turn out, is increasing as long as marginal revenue is greater than marginal cost. Right? So if we gain more revenue by producing the next item than we incur by producing that, or then cost we incur by producing that next item, then it's beneficial to produce that next item. Right? So to maximize profit, what we want to do is increase production to the point that marginal revenue and marginal cost are equal. Because if we go beyond that point where marginal cost becomes greater than marginal revenue, then we start losing money. So we essentially want to produce up to the point where the two are equal. All right, so let's look at an example here. Right? So here, I think this refers to an example we didn't do here. But let's say we have a furniture manufacturer, and they say their revenue function is given by R of Q equals 48Q minus 0.012Q squared, right? And the cost function for producing Q chairs is 10,000 plus 5Q plus 0.01Q squared. Oh, this actually was the... Sorry. This actually was the one from a previous example. Oh, okay. So, let's go ahead and try and compute this here. Let's look at what's the marginal revenue when 1,500 chairs are produced. And then we want to determine the number of chairs that the company should produce in order to maximize profit. Right, so let's go ahead and move over here and do this computation. I'm actually thinking in the last video. Yep, okay. That was the same example from the previous video, but I lost a 0 in the last one. So we'll do this again here. So the first part of this question, we were asking what's the marginal revenue at producing 1,500 chairs? Right? So we first want to compute the marginal revenue, which is 48 minus 0.024Q. And so the marginal revenue to produce 1,500 chairs is 48 minus 0.024 times 1,500. And if we pop this into the calculator here, we get 0.024 times 1,500, and then 48 minus that. So we get that this is 12. So this is saying to produce the 1,501st chair would give us $12 in revenue. Right? So what we want to do to maximize the profit, remember, is we want to say C prime of Q equals R prime of Q. All right? We want to maximize the profit, so setting these two equal to each other. All right, so let's go ahead and compute this. We have 5 plus 0.02Q equals 48 minus 0.024Q. All right, so we just have to solve this equation here for Q. So I'm going to put the variables on the left, the constants on the right. This will give us 0.044Q equals 43. Right. And now divide this by 0.044. All right. And here Q is about 977.2727. Right, so how many chairs should we produce here to maximize profit? Well, we would say 977 chairs should be produced to maximize profit. So again here, for maximizing profit, all we're doing is setting marginal cost equal to marginal revenue and solving for Q. And that tells us how many chairs should be produced.